Today I'm going to tell you how I used Midi in a Web3D browser, freeWRL. I'll give you some references, show you about Midi 2 versus Midi 1, show you how I routed and sent the packets through, show you my proposed node set, show you how to hack the packets, and show you some demo scenes. This first link will get you to all of the documents I'm going to show you. What is MIDI? Musical Instrument Digital Interface. There's a MIDI.org that has specifications, and this year they published MIDI 2. Web3D has a sound component, but no MIDI. It has an oscillator node. In my case, I just added another component, 43 MIDI. There are some standards for MIDI for web MIDI. And some documents for developers. Much the same thing, web MIDI. Web MIDI is currently version 1 of MIDI, not version 2. Operating systems don't yet have MIDI 2. And for desktop applications, there are some native libraries. MIDI 1 came out in the 1990s. It has a message, which is a string of bytes. If you press a single note on a MIDI keyboard, you'll get 3 bytes. And it deals with input and output ports. The input port would be where your notes are coming from. For example, an external MIDI keyboard, USB plug-in keyboard, and an output port would be something like the operating system built-in MIDI synthesizer node, which converts the MIDI messages or packets into sounds that you can hear. MIDI 2 came out in this year. It has packets, 64-bit packets. And when you press one note on a MIDI keyboard, you'll get a 64-bit packet. Instead of ports, it has bidirectional endpoints. And in the MIDI 2 protocol standard, see Appendix D on how to convert between MIDI 1 and MIDI 2. I'll show you a little snippet, but it's several pages. Should it be indirectly routed by the browser, each packet? Or should it go through routes in the Web3D scene? I used a combination. If I'm just going from an input port to an output port, it'll be kind of the behind the scenes implicit in the thread of the input port. If I want to process it with a Web3D node with routes, then I'll use routes. and some proposed node sets. I've got the fields and node names. None of this is in any Web3D specification, so it's all subject to if or when or how it would look in the final end. This is more like a prototype, a first attempt, proof of concept. And I have most of these implemented. Some source nodes and destination nodes, some nodes that kind of break out those packets. So if you get a stream of packets coming in as MF doubles, each double being a 64-bit packet, then this tone splitter node would break it up into uh, events on each key in an octave, and then there's a field that allows you to filter for a specific octave. So you'd have a number of these to cover, a whole keyboard. And similarly with a tone merger, if you have general events in Web3D and you want to kind of convert them into notes and into MIDI packets, then you'd have something like this. A few notes I didn't implement. One here for MIDI program that I did implement. It has an int instrument number and a delay node which has time in seconds to delay a sound. You could develop a MIDI audio synthesizer to replace the operating system synthesizer, and you could use an array of 8 sound oscillator nodes to represent 8 polyphony of 8 keys. For example, if you press 8 keys at once, that's a polyphony of 8, and you'd need 8 oscillator nodes, and you could recycle those oscillator nodes as different keys are pressed. Notice I have both a MIDI message and a MIDI UMP. But in freeWRL, I only use one at a time. I have a command line parameter to say which transport protocol you want, MIDI 1 or MIDI 2. If you say 1, you get these MIDI message events. If you say 2, you'll get these MIDI UMP packets. So I'd have a port source, file source, and then some destinations, a port destination, of course. I implemented a print destination for debugging so I can make sure that the messages are getting through to the end. I could have implemented a file destination, but didn't have a case for it myself. To go from the MIDI source node thread message passing into routes, I have a MIDI out, and then going the other way from routes back into the thread messaging, I have a MIDI in. The tone splitter and tone merger I showed you before. How to parse a packet. That's 8 bytes, 64 bits. There's something in the ECMA script called data view, which allows you to look at it from as a 64-bit number or a unsigned 8-bit array or 16-bit ints, and then you can extract various elements from the packet: channel, command, note, and velocity, which is like volume. Or going the other way, you can construct a packet. The equivalent in C++ is to use unions, and you can get at those bytes or 16-bit ints as you need them. Let me show you some demo scenes. I'll start with showing you the scene file. I have a couple of geometries, a white key and a black key, and then a script node. And in initialize, it goes over 88 keys, constructing an 88 key keyboard as the MIDI packets come in. I parse the packets, convert to a note number, and then I do something with the geometry. I change the rotation to make it look like the key is being pressed. There are my MIDI packets in use. I also go to the output port so I can hear as well as see the keys being pressed. And for this scene, I input by pressing on a keyboard like this, which is USB connected, so it'll be on an input MIDI port. I'll show you the scene in action. I'd call that a player piano. And for a playable piano, one that you can click with a mouse, I generated it with a Python script. Let me show you the Python script. It's got a couple of geometry nodes, again a white key and a black key, and then a script that goes over 88 keys, assigning a note number and generating geometry, some routes for each key, touch sensor orientation, interpolator, etc. for each key. I'll briefly show you the scene file, give you an idea what that looks like. 88 keys worth and the routes that go with those. That's why I used the Python generator to save from typing all that by hand. Let me show you the scene. And I'll be pressing the mouse button to click the notes. I wanted to show a scene that isn't necessarily about the audio or sound. You can use MIDI sequences from a keyboard or a .mid file to sequence general events in a Web3D scene. Let me show you the scene file. I have a particle system, force physics models, explosion emitter. I have some MIDI ports. You can also hear. Notice I've got a MIDI program node. It has instrument 119. And I've got a delay of 2.4 seconds. And down here I have a tone splitter, and I wrote from middle C to the particle emitter. Let me show you that scene. And let me show you the instruments that you can choose. There's about 120 of them. The first one, the default, is acoustic grand piano. And for my fireworks scene, I chose 119, which is a synthesis drum. That's it. Thank you for listening.